let's see. Last time out, we was finishing off the rendering of the screens and getting the custom graphics in place. Now, I've done a little bit of work. I've done a little bit of work on it. So, just to show you, here we go. Oh, look. So, those eagle-eyed amongst you will see the difference. And those who are not eagle-eyed won't know the difference. So...
You've not done the gate yet.
No. It's the air bar.
I was going to say, you've got a full air bar.
Yes, it's the air bar. Because I was looking through this. I nearly got it assembled, compiled. I nearly. But then it kept complaining about libraries missing, so gave up. But I was looking through the code, and there was a line in the code. Hang on. There was a line in the code. Where is it? Come here. Right, and it was. Where is it? Right, it's not that. It's not this. It's this. Right, let me just boost it so you can see it. It's this line. These two lines here. Right? And I was thinking, what on earth is that? So I had to find out what memset is. And memset is it sets a number of bytes. So what it's doing, it's saying start here, put that in for that many iterations, right? I thought it was just the one, but it's not. It's actually a thing. So I changed the code because, once I realised what was going on, I changed the code here. So here it is. I changed the code. So it works out how many characters the airhead is, then increases it by 1 because we've got the head on it, and then we run through that and we get our full air bar. Yeah. I've also
Phase 101.
Hey Phase, welcome in, mate. Welcome in. So we got the full air bar, and I've done the code for the conveyor belt, but I've also done some other stuff as well. So I have split out. Hang on, where is it? So this is the prep background characters, yeah. But as you can see, I've commented out a big chunk of code because I've actually split it out. So I've got this build world collapse characters, and I've changed it as well because I thought, right, so this is what was there before. So it was load world collapse 1 character and then times it by 8. But it's a immediate value. So I thought, sod it, do it here, then we can get rid of this, yeah? And this, and same with here as well. So this does the world collapsing character. And then I've done the conveyor one as well. So I've actually done the conveyor one. I don't know if it works yet because I've got to check the memory. But I've done the same thing as in the C++, the C. So we load the full character, we load the proper character, we check to see if it's Y0 or 2, and then we mess around with it. So I pushed it, I ended it with C00, which gives us the last two bits. Then I rotate them round. I rotate them round so they become the first two bits. Store it away. Then I bring it back. And then I shift left the rest of the character. So it moves over. And then I ore what I've just done here back onto the character and then send it to Vera. And and it's the same with this way, but it's going the other direction. So we've got to see and make sure it's done it. And then I did the air characters here, which was just basically a straight copy. So that's what I've done. Oh, is it?
So what's left? There's gate to do, and is that it?
Say again.
I know you've still got the gate to do because the 4 characters for that get redrawn each level, don't they?
No, the gate's a sprite, mate.
Is it?
Yeah.
It might be in his version, yeah. I was looking at the original, not the Steve version.
Yeah. So now what I'm thinking of doing is let's see if we can get the sprites on the screen. Not moving, but let's see if we can get the sprites set up on the screen. Because, like I say, I've got all this done. I've done the air one. So, I have imported and understood the sprite array that's in the C program. So this is the sprite array. So we've got level 1. So there's 2 sprites on level 1. Yeah. We've got a sprite. Yeah. So it's going to be that little man walking, and then we've got the door sprite. Yeah. And I've worked out all these elements. So these zeros here, right, are the working storage. They are the working storage. So the first one is where it is, where it is. Second one is what frames it displaying. Third one is which direction is it going. Fourth one, is it enabled? And then they've got this one called local storage. Now I ain't figured out what local storage is yet, so no, we're getting there. So with this sprite, the minimum is 64 and the maximum is 128. Yeah. So, but if you look at the class, it says horizontal. That means that it's 64 to 124 horizontally, and that's its range. Then we've got this, which is where it starts. So it's going to start at 64. The other axis. So because this is horizontal, the other axis is vertical. It's saying it's going to plonk this sprite at Y56. So, yeah. I'm still not sure about that, to be honest. But because these numbers are going to have to be changed, because we've dropped down the screen by, I think, 4 rows, I think it is. So we've got to do some jiggery pokery, yeah? And then we've got this one, which is what speed it's going at. So this looks like it's moving 2 pixels every frame. And then this one is the frame index. So I haven't figured out what the frame index is. So I'm not sure if it's the start of the frame index or what. But there we go. Then we've got the colour of it. Yeah, okay. And then we have got the start direction, the whether it's enabled or not, and then the type of it. Oh, let's have a look. Hey, Docster, welcome in.
You're not going to need the colour, are you?
No, we're not going to need the colour. Alt Control Delete, welcome in, mate. Welcome. So, we have got 1, 2, 3, 4, 5.
Why don't you have the colour?
Because the sprites are all multicolour, aren't they? So we don't need the colour.
Oh, yeah. Okay. Ignore me.
But I think I think we're going to need the colour for the gate. I think.
Right.
Because we haven't got the gate, I don't think.
Yeah, you're not going to change the layout of the table, so the information's still going to be there. You just won't need to use it for the animated sprites.
No, because I mean, the gate is different colours, yeah? So that means that the sprite is a different colour for the gate. But we can create another table just for the colour of the gate. But
leave them colours for the when you have it, switch it to classic sprite mode.
well, yeah, but we can create another array because we don't need these colours for the other sprites. Even though these colours, so on each level the sprite could be a different colour for on the level. We haven't got that. We've got nice multicoloured sprites, so everything's gonna be the same, looks the same because of the multicolour aspect of it. You know, SPs. But this is the basic. This is the array and how it's worked out. Yeah, and then at the bottom here, we've got an array that tells where the array is. Yeah, so level 0 is going to say, right, we need to look at array index 0, and we've got 2 sprites on that level. Then this one's going to be index array 2, and we've got 3 sprites. And it all works out all the way down to 102. Yeah? So this is our sprite. Now, we need to work out how we're going to put the sprites on the screen, because the C64 is 64 bytes per sprite, and we've got 128 per sprite. And I was trying to think how we can calculate that quickly.
Table.
Well, I was thinking, won't it be quicker just to multiply it? But we could have an array, yeah? We could have a lookup table like we've got for the times 10 and the 32s. But we need to sort this array out. We need to figure out what we need to keep and what we need to lose. So looks like we're going to... Go on.
To work it out, rather than multiply up by 128, put the number in the high byte and divide by 2. And roll the bottom bit down.
That works.
Yeah, that works. That does work.
And that'll give you an offset from base.
Yeah, that works. That does work. Hang on. Have we got a utilities? Because I've got... Where is it? Oh, have I passed it? Ah, there. So we've got that, but that's part to do with the render. I suppose we could put it in here as well. So let's say set sprite definition address. So the input is the character sprite number to set, and we just need the place where we're putting the sprites. Now the sprite address is there, isn't it? There. So let's do that. Right. I am going to change this and make it a bit more permanent. So I'm going to change it and make it a bit more permanent. I'm not going to use this. I'm going to create a new one called, what did I call it? Cell address? Yeah, cell address. Cell address. Right, 0. Right. So I am going to get rid of that. So if I look for that, find, then I can get rid of it. Right, so there's 3 instances, so I'm going to get rid of that one there. Where's the next one? Yeah, we'll get rid of that one as well. And the next one, get rid of that one. Now, I need to look.
It needs to be a word as well.
Yeah, and then storage dot render dot go. Oops, undo. Cell ADR. Blink. There we go. Right. So that's sorted that out. So now we've got a permanent storage location of where we're not going to use the temporary ones, right? So Saucy was saying, right. So if I do stz that, so if we zero out the low byte, and then so Saucy was saying rotate right our number. No. Logically shift right our number. And then rotate right our low value. And then store into the high byte. Then we can do add the memory, the lower memory address to Vera and the other memory. There we go. That does it, doesn't it? That does it. Right, let's just put each sprite is 128 bytes. Right. So now we've got a sprite definition. Am I missing something? Off to alert mode. Right. So we need to bring in the sprite. So we need to bring in the sprites. So I had a bit of an issue. Oh, was it because I didn't do this? Or maybe it's because I didn't do that. Come on, John, keep it consistent. Right. Now, let's fire up the sprite editor. So we are loading, I think it's 20. I think it's 20. Yeah, it's 20. Right, so SP, the palette didn't change, yeah? The palette didn't change, yeah? I assume that's a no. Right, save. Oh, minor colour. Right, we'll export the palette as well then. And then we'll figure out how we're going to do that. Right, git. By the way, that's not me tip-tapping, by the way.
Oh, sorry, mate.
No, it's alright, mate. It's alright.
The phone's right back next to the keyboard.
Yeah, no worries. Right, so keep. Right, let's have a look. So we should have enemies in here. Yeah. Right, so as you can see, this is the new exporter, so you can see what the sprite looks like. Right, so hopefully we should be able to do this. Probably spelled enemies wrong. I don't care. I don't care. Hey Rob, welcome.
Get rid of the R and it'll be fine.
Get rid of the R?
Yep.
Okay. Right, but this has got the palette at the bottom. Hang on, palettes at the bottom. Let's get rid of that and create a new file. Do that. So we'll just split them out. Why is that complaining? Flagtail 2, I bet that exists somewhere else, doesn't it? Yeah, there. Flagtail 1, Flagtail 2, Flagtail 3. I bet that's 4, isn't it? I bet that's meant to be 4. There we go. Right. I don't think we've got the... No, it's not. It's not in here. Right. So, you should be fine now. Can't open... Really? Enemies. That's what I've called you. Ooh, right, okay. Let's put some stuff in here. So, sprite data and chart data. Let's see what's going on. Are we blowing something up? Why have we got a default?
That's because of the macros. Because you've got 4 bytes of variables stored in your macro ASM. And it does stupid things and I couldn't work out how to fix it.
Okay, then we'll put it there. We'll put it there. Right. Let me shut this down and I'll redo it. Okay, so it's still breaking. Right, so we've got rid of the default. So why is it breaking? Why is it breaking?
No idea, because that shouldn't be a problem for memory.
No. I wish it would. I wish it would do. Tell you what the macro call was before it, as a comment or something, so you could see. There's definitely a delay, isn't there? Right, let's do this. Let's see if we can figure out where it's breaking. So we'll put a break there. And see if it's breaking there. Right, so it's not that. So it's not the sprites. Let's do that one there. So it's not that. We'll get there in the end. We'll get there in the end. Okay, so it's not that. So it's not that. Oh nine CA. Okay. So it's not the copies. 09 CA. Let's have a look. 09. See there. Why is it jumping ahead by 1 byte?
Keep scrolling up a bit, John. Scroll up.
It's going halfway through.
Yeah, go up a bit. Above all your variables, what's before that?
It's just all the storage.
Oh, you've got, I'm just making sure you've got an RTS before you fell into that storage.
Yeah.
I know what's wrong. And I told you this when you made it. Sol address needs to be a word.
I can confirm you did say that.
Which means you're changing that STZ instruction to something else when you put something in sol address +1.
Yeah.
Rookie mistake.
You look, you've got yeah. 10 lines of code, mate. That's the limit.
That's it. We're done. I think you've done that, John. We can pack up. Go
You
on.
have to work though. I'll be fully optimised.
Yeah. Right. So we are fully optimized. Yeah. We should be able to now. Right. Where's Wiele? Where's Wiele? There. We set up the sprite. Set sprite address in Vera table. That we've go on. Where's the macros? Right, where is it? Set sprite. Set sprite address in Vera table. So we do this. We don't need to do that 128. Oh, we do. We do. Because that's setting it here, isn't it? But that's not set in the set sprite address in Vera table. Is that the one where we're putting an address in? Address frame number. Ah, right. So it's this one we need. Okay, let's go back. Let's go back. Is that what we're doing? Set frame address in Vera table. Where's it gone? Macros. What did I call the other one? Set sprite address. Yes, right. Set sprite address in Vera by table. Okay, by table. I'm gonna have to name these better. So we don't need. Oh, we do need to work out. Okay. Sprite address table. What is that? Where's that sprite address table? Ah, here. Right, so we've got 8 for Minor Willie, and then we've got 108. So that's 116. Oh, we've got some bots. Oh, hang on. Hang on.
You got what, Mr. Jumping and Sorting?
Say again?
I was going to say the moderator's not on the ball, is he?
Sorry, mate, I'm doing something at the moment. I'm working.
That's alright. That's alright. I'm getting them. I just don't want to ban the wrong person. There we go. There we go. Oh, Icon Pressers resubbed. Did that not pop up? Icon Press, thank you for resubbing, mate. I'm not sure why my thing didn't pop up. But thank you very much for resubbing. Right, so that's right. So this is the address. Now I'm just wondering whether I should put this into game data under lookups. Let's cut that. Put it into game data under lookups. Right, so game data lookups. Right, so game data dot lookups dot. Right, we're going to see if we're still. We're going to see if we're still working. So, is that the only one? Is that the only one? I've got me tests, but I don't care about that. Right, let's see. Right, F6. Let's see if Minor Willie still moves. Right, okay, so we ain't broken Miner Willie. Right, he's still there. Are we still jumping? Yeah. Right. So,
what's cooking, Doc?
Yeah.
Right, WebSockets is working.
Is it?
It is.
I've done the conveyor. We just need to check that the values are right. But we're just trying to load the sprites in and figure out how we're going to, you know, access them. Macros. I need to see the sprite number is going to be a fixed number. The frame number is going to be an address, and the sprite address is going to be address. Okay, so that's going to be fixed. We may have to make another one where that's an address as well, I think. Yeah, I think. But we'll... Right, let's look at how we get the sprites in. So have a look how we get the sprites in. Oops. There we go. Right. So this is the prepping of the sprites. So I'm not too... So they're the sprite pointers. So he's in the upper part of memory. Sprite offset is divided by whatever. Sprite RAM. Oh right, he's working out the base pointer. Okay. So that's the base pointer. Okay, so for sprite equals the sprite index. So where's the sprite index? Sprite index. Oh right, okay. Is count first? The count? No, is the count a second? Oh, sprite count. Here we go. So the sprite count is equal to the count plus the index. What? So this is the index. So the sprite count is that plus that. Oh, I see. I see what he's doing. He's going from 2 to 5, which would be 3. Oh, here we go again.
Another bot.
Yeah. Goodbye. Right, I see what he's doing. So he's...
Yeah, it saves you adding it up along the way. His first number is the where you are in the index.
So then he's...
The first byte is the index and the second byte is only sprites.
Yeah. So then he's going to sprite data, which is this. That's sprite data. So he's getting the sprite data for the relevant thing. So, okay, because the array is going to be 0 to 100 and whatever it is, he's using that to map to the array directly, isn't he? So on level 1 we'd be looking at array 2, 3, 4, 5. Level 0 would be 1, 0 and 1. Okay, so he's looking at the array. Sprite bit. That's got to be the enable, surely. He's putting 1 into the first bit. No, he's shifting over 1 and then putting 1 into the first bit. I bet that's the enabler. Then the colour. Well, we don't need to worry about the colour. If the sprite class is Kong or Eugene, then the enable is the sprite. Okay, so let's say it's the first one, so that would be 2 minus 2 plus 1. Huh? What? I get this. I get that. I don't get this. Sprite current enable is equal to... So if it's the first, let's say it's the first sprite, so that would be 2 minus 2 plus 1. Why can't it just say 1? Current enabled equals 1. In what universe would that be anything other than 1? Oh, if it, let's say it was 3. 3 minus 2 is... we'll have to investigate that.
Well, that only applies for Con and Eugene.
Yeah, it only applies in Cotton and Eugene. Okay, well I know what this is. This is setting the XY. So if it's vertical, it's
Con and Eugene have special features. They're like they fall into the pits and stuff, or they go down, so the behaviour changes.
Yeah, but I'm not sure what this enable thing is. We'll figure it out. We'll figure it out. So this is saying if it's vertical, then the position IPOS will equal the current. Sorry, if this is not vertical, then the I position will equal the position specified in the array, and then the Y will equal the other axis thing. But if it is vertical, then IPOS will equal other axis and the Y will equal the current position. But the current position is 0. Or did we grab that? Because it would be the start position. This looks like it's the high byte, the most significant bit byte. Pointers. No, position. That's the position, in it. And now this has got to be the copy, surely. Oh, user index. Used index. Where's that? Use index 8. From 0 to the frame. Now the frame, I think, is the number of frames. Hang on. Where's frame? There. Is it grabbed anywhere? No. Okay, so what's index? Index is equal to 0. From, okay, where's index? Eight sprites. Is that working out? I really should have looked at this before I started.
Index starts at 0 and increments once through each loop.
Yeah.
Is this all the frames for that sprite?
Well, that's what I'm just wondering. But the thing is, even in the original, hang on, where's the data? Even in the original, because SP's been copying, you know. So here we go. What? Right, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right. Okay. So I think I know what's going on. So we've not been doing 4s. Because the frame repeats, so it'd be that one, that one, that one, that one, or would it?
I asked this earlier because some of them have only got 3 frames and some have got 4.
Yeah, so that one would be that one, that one, that one, that one. That's it. That one, that one, that one, that one. That. I think that's what that code's doing. It's taking the 4 frames, but.
So it's building everything based on 4 frame cycles, but where you've only got 3, it's gonna.
Yeah, we've got a problem, and also there is this thing called full frame, where it becomes there's 8 frames in that particular one. So when a sprite is a full frame, so let me just find one that says full frame. There are full range. There we go. So that's Eugene. Hang on. Have we got any others? Full range. What's that one? Kong. Oh, here we go. Full range. So what's that one? Level 7. Right. Level 7.
Isn't that more of a state table? Because, like Eugene, when you get the last key, just falls, as opposed to doing his full range of motion.
Yeah. But I've just picked out a sprite that says full range, and it's the bouncing kangaroos, isn't it, on this one? And SP has got it as here for but I think it does that. So that's 1, 2, 3. So we've only got 4 frames for the kangaroo. Okay, so that's 1 and 5.
SP said the other day, didn't he, that some of them are doubled up?
Yeah, like these two. So that's 1 and 5, 2 and 4, 3.
John, look at text.
Yeah, it's a 4-frame loop. Okay.
No, the line above that.
Just sent an additional sprite for game over.
Oh, sorry, I misread it. I thought he said he sent some more sprites over.
That's what I thought he said first time I looked at it. That'll be the boot that falls down, won't it?
Yeah, I'm a bit busy tonight, so I've only got half an hour in it.
Yeah. So that's all. Oh, and one's disappeared as well. Okay, let me export that. We won't do the palette because we've already got that. Enemies. Alright, so because we are not having the static number of frames, which is in here, which seems to be 4. That's 4. 1, 2, 3, 4. 1, 2, 3, 4. Eugene is just 1. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. That's 2. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. See, they're all 4. Oh, this is not. 1, 2, 3. Oh, it is. Right. So we're gonna have to rejig this. Okay, so we're gonna have to think outside the box. Because I don't think he's copying. I don't think he's copying the sprites. I think he's copying the frame. Is he copying the frame? Frame. So he's finding the index. He's finding the index of the frame. If the use frame is equal to frame index. Oh, I don't know what he's doing here.
John, just highlight that entire function.
Put this one.
The whole thing, and then hit delete. Then write it properly.
Right.
Because you know exactly what he's doing, right? All he's doing is he's taking a start and end position for a sprite, a direction it moves in, and moving it on every frame.
Yeah.
And when it's then turning it round, I don't understand why you go into his shit code.
Yeah.
And also, writing in C is not going to translate it to writing assembly because it's chalk and cheese.
So we need to write a function that does the same as that, but not that. Well, I think we're going to have to create a table that gives us the frames for each of the dudes, each of these, right? Because we haven't got the frame, we haven't got the sprite going backwards because we're just going to invert it, yeah. For the ones that turn around. Right, so the 4 frames, 1, 2, right, has he named that? 1, 2, so that definitely walks like that. 1, 2, 3, 4. 1, 2, 3, 4. One, 2, 3, 4. Then does it go back to that? No, it can't do. 1, 2, 3, 4. It must do. Okay. Right, so this is the frames for that. So 4, and then we'll work out the 4 for that. So we need to create a table with the frames in, with the frames, so we can create them all to be the same number. So that's going to be 8 frames. 2. Hang on. 2. 4, 5, 6, 7, 8. Right, so that's 8 frames. And we got this one. That I think this is 8 frames as well, isn't it? 2, 3, 4, 5, 6, 7, 8. Right. And the rest are 4s. Right. Okay. So we need to create an array that tells the system which frame to put in when. And I think that's what we need to do in the setup.
That one with the Skylabs thing, 3rd row up, it drops the same one all the way down until it actually crashes, then it animates.
Yes, yes. But we're just setting up. So what we need is we need an array. We need an array that's going to define all the frames for each of the bad guy, yeah? And we need an array that then reads that array and stores it in a common array so we can just run through it. So if it's a 4 frame, we'll just run through 4 frames. If it's an 8 frame, we'll run through 8 frames, yeah? But as you said, with the Skylab, it's always going to be that one until he hits, and then we have to run through the frames. But I think we only need to do the pointers. I think we only need to store the pointers. We don't need to tell it So we need to just we need to store the pointers. Right. So let's go into storage. Right. So what do we need? Sprite frames. We've only got 8 on the screen at any one time. Word 0. Oh no, but that's not it, is it? Right. So it's a 64 byte array. For 8 sprites. Oh, is that gonna work? Well, what I'm trying to do is I want to copy the frames into the sprite array, so we don't have to keep going off. We just do it the once and then just run through the frames of each of the sprites, so we don't have to worry about what we're doing. So sprite 0 will be Miner Wiele. Then we've got 1, 2, we've got 7 other sprites after that, and we just run through it. That should work. But it won't work. Will it work for the ones with 4?
Can you not just make a big array of the order of each one and use an index into that array to pull out the frame
Well,
of the sprite?
that's what this is here. You know, the first 4 bytes here of this array is what we're going to use to control. But it's I'm thinking about the frames, yeah, not where it is, but what frame are we going to display? Because there's no. I think that's what he's trying to do there, is create a frame, an array of all the frame numbers. So when you run through the frames, it's doing it. And I'm thinking that this will do it, because we only need to know what the frame number is, because then we can go off and work out.
Yeah, if you just had like an array now of like the frame orders up to 8, because the biggest one's 8 frames, isn't it?
Yeah.
So the ones that's only 4 frames, they'd repeat twice in the array. So you're always using the same, looking up at the same position in the array. The ones that use like 3, where it uses one sprite twice, it'd say go 1, 2, 1, 3, 1, 2, 1, 3 in the array. And then it just gets your sprite number for which one it's looking at and counts into the index for the frame that it wants.
Yeah. I mean, we can try this theory out. Just by going into here. And before we start Miner Wiele, we'll set it up. So LDY #0 store y in storage store dot that comma y. Oh, we can't do store y comma y. Hang on.
That would be an endless loop, wouldn't it?
Yeah. So I'm just trying to. Let's do it a quick way. Let's do this. So store in frames, then I and y. That's 0, 1, 2, 3. That's for Miner Wiele, but we need to work. Oh, Miner Wiele, where is he? Do we just do the 4 frames or the 8? Hang on. The animated the sprite frame. So we do. Oh, we do 8. Miner Wiele hasn't got 8 frames, has he? Oh, he hasn't got 8 frames, has he? Where is he? Where is he? 1, 2, 3, 4, 5, 6. Oh, he has. Okay. So 0, right. So that's 0, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8. Right. So instead of using this, we would use the frame counter to look into that frame array. Right, let's do that. Okay, so let me just rem this out. Transfer it into Y. So that's between 0 and 8 and then load the frame. No, I need that still in there. Load this, comma Y, which would be the index, store it in the sprite frame. Right. Do we get the same result? This is just a... Surely me wrapping that round should have stopped that. Hang on. Oh, I didn't do that one. Hang on.
Why are you storing Y in the same location so many times?
Say again.
Why is storing Y in the same place?
Oh yeah.
You can use X and store Y, comma X, you know.
Yeah. Right. Let's get rid of that. So 1, 2, 3, 4, 5, 6, 7, 8. So 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7. Right, that should do it. Hopefully. Right. Oh, you git. Storage sprite frames. Oh, render. Right. Go. Does Miner Willie still work? Oh, we're still... Have I missed one? Oh, yeah. What? Store Y doesn't support app. Ugh.
What did I get? Is it store X, comma Y you can do? What you can do one of them.
No, they're only 0 page. I think they're only 0 page instructions. I think that's the problem. And I'm storing it in.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Who's followed? Say hello. Who's followed? Don't be shy, we don't bite. I may moan a lot, but we don't bite.
John, which one's 0 page?
Ugh. Store Y, comma X. I think it's only I think that's only 0 page. 9F4. 9F4. Right, let's have a look at 9F4. Have I got it wrong? Oh. Right, F12. Memory 009 FO. Oh, I'm only storing. What? I increased.
Yeah, you're right. It is only 0 page.
0. This has got to work. This has got to work. Well, that works.
That's cheating.
Say what?
That's cheating, jumping and walking through the walls into the box.
Well, that works. So if we copy the frames from the array into this working array, then all we have to do is look through the working array to then do the animation, because then we're only fixed in one place. So that works. So we just need to make the array that's going to point to all the different numbers. I hate this game. Right. Game data. Right. We need to create a frame, sprite frames. So if we keep the philosophy that these that's the framing. So these are the right. So this is basically saying what the frame index is. Right, so we need to convert these into bad guys. We need to convert these into bad guys. Right, so Miner Wiele. Right, dot byte. So 0, 1, 2, 3, 4, 5, 6, 7. That's its frame indexing. Don't need that. That's its frame indexing. So, we need to name these fellas. We need to name these bad guys, don't we? Let's see. Is there a name on there?
Give them all names, don't they?
Yeah. Right. Robot Walker. Right. Let's get this sorted. Right. Robot Walker. And we're going to make them all 8 frames, right? We're going to make them all 8 frames, so that's going to help us when we work out the drawing. So in terms of this, so everything is going to be plus 8, right? So let's try and get this into some sort of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right, so we got them in tens. So that's going to be 8, 9, 10, 11. So 8, 9, 10, 11, 8, 9, 10, 11. Next one. Penguin. Penguin. Right, dot byte 12, 13, 14, but that's not the same, is it? Right. So the second one is repeated. So 12, 13, 14, 13. 12, 13, 14, 13. So we're going to do this on all of them. So that's the same.
You're doing it a bit different to how I would have. I thought I would have done it.
Chicken. Why? What?
I'd have had my frame counter counting through from 1 to 8, or 0 to 7 continuously, and then looked up the name of the sprite and then had it as a frame count of 0 through 8, 7 for each one. Do you know what I'm saying?
Yeah, but you need to know. You need to know. You need to know what animation it is.
Yeah, you're indexing them all from 0, aren't you?
Yes.
For each sprite.
So,
but I would have looked up the sprite name because you've labelled them, and then just took the index from that.
Yeah, but the problem is, right? Because each level has a different bad guy, and we're going to use the same 8 sprites for each level. You can't do that, yeah, and that's why.
I'm with you now. Yeah, you're actually pointed directly to the sprite, aren't you?
Yeah. So what happens on level 1? I'm going to copy that array into that other array that we've just been messing around with, yeah. And then we're going to use that other array. So it doesn't matter what's in that array as long as we keep the 8. But we need to sequence all these bad guys to make sure we got the 8.
Yeah, you're indexing them from the sprite 0 actual location.
Yes, because that's how we're going to reference them, yeah? So Minor Wiele is the first 8 sprites. Then the Robot Walker is the next 4 sprites. And then Penguin's the next 3. But we need to convert those 3 into 8, yeah? Right, Chicken is...
hold on, John. In your other table, you've got your frame index for the sprite, like 8 or 15 or 26 or whatever, which tells you what the first sprite is, yeah?
Yeah.
So in this table, do you just really need, like for Robot Walker, 0123, 0123, and then add it to the frame index from...
Yeah, that's where I was coming from.
So you get the frame index from the table, and then you use the sequence from this table, which can be 0123 or 0121, 0121, etc.
Yeah.
That's what I was trying to say in a roundabout way, Tulsi.
Yeah, I thought that's what you were saying. Yeah, that's not 123, not 123. I'm just thinking,
You can just add the right index to it, can't you?
You might find there's only a few sequences, in which case it might be easier to have a pointer to the sequence number. Keep going and see what it looks like first.
Yeah. So the Penguin...
You might find that Penguin and Chicken are the same, so you could just reference sequence 3 for penguins and chickens and so on. I don't know.
Yeah, because if you're not using colour in that other array, you could change that to your frame sequence, couldn't you?
Yeah. Yes. Yeah, you're right. We could use that column. Hey, Cold Hands. Hang on. But I've got a sneaky suspicion.
In the mystical land of retro computing, the old school coder embarked on a quest to port the ultimate game, Manic Miner. Willie, our pixelated hero, had to escape from the clutches of Buggy McBugface, all in glorious 256 color glory. And so, dear listener, if you stumble upon Manic Miner on your vintage X16, remember old school Coder, whose mind exploded on in 16 glorious bits by the task.
Someone's got to clip that. Someone's got to clip that. That is brilliant. Hang on. Hang on.
Never heard that listening on Discord.
You don't hear that on Discord. Okay. Hang
No.
on. That was brilliant. That was brilliant. Hang on. Can I download that? Oh, will it let me download it? No, it won't. Won't let me download it. Oh, that's not fair.
You have to get it clipped and then play it back. Where's FaZe? He's a clip master.
Yeah. Oh, that was brilliant. Yeah, I can't download it. Oh, that was I can play it again, but I just can't. I can't download it. Someone clip it. Someone clip it, because that was brilliant. That was brilliant. That was. I might be able to do it in Video Producer. Oh yeah, yeah. Hang on. Let's. What time was it roughly? 1 hour 40. Right, 1 hour 40. Let's see if I can grab it. SP's done it already. Look. Right. So 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So they've got 40. There's 14. So we can.
There's 15 bytes.
Yes, 15 bytes.
Which is silly, because if you make it 16, it's easier to cycle through it.
Well, that's what I was just thinking, mate.
Yeah, I was counting while you were doing the thing and thinking, you add an extra byte and call it the sprite animation index or whatever, yeah.
Yeah, so if we, because like you say, this frame index, if that's the actual start frame of the sprite, then we could use another column, this one, say, that would say which of the animation sequences that we need to use.
Yeah, and that was the start frame for the bad guy. So there's two bad guys on level 2, but both the same sprite, 17. But that's assuming that SP hasn't changed the number of frames for each sprite.
Well, he has, so we'll have to work out.
We'll have to recalculate
these numbers. Yeah, we'll have to work out all these numbers. But yeah, that's a damn good idea. So, in terms like the chicken, yeah, it's the same sequence
as a penguin.
As the penguin, so I'm just wondering.
Now, I think you'll find there's only going to be a few sequences. There'll be like 0, 1, 2, 1,
yeah,
3, 0, 1, 2, 3.
Okay, so level 2 sprite frame sequences, yeah?
I'll just call them 3 sprite, 4 sprite, 5 sprite, or whatever.
Yeah, so
that's what it'll work out as.
Ooh.
Oh, can't. 8 frames.
My laptop's just died.
Frames. 3 frames. So what else we got? So we got 3 frames there. 1, 2, 3, 4, 5. We got a 5 framer. Right, so what's that 5 framer? So 1 and 5,
Just
right?
remember,
So
the 3 frames ones, like the telephone, is actually a 4-frame animation.
yeah. Right, let me do this.
Yeah, we've got to tell it which order to play the frames in though to make 4 frames SP.
So that's 1 and 5, so that's going to be 0 and 4. 0 and 4 is 0. Okay. 2 and 4, which is going to be 1 and 3, is 1. So 1 and 3 is 1. That one is 3. So that's going to be 2. That's there. So 0, 1, 2, 3 is going to be 5 and 7. So 3 is going to be 5 and 7. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4. So 4 is going to be 6. So that's going to be 0, 1, 2, 1, 0, 3, 4, 3. Okay.
You want a row of zeros as well for 1 frame for the parachute things.
Yeah.
But don't they specify not animated in the table?
Yeah, it could be. It could.
Or does it? You know how many? Does it say how many frames there are?
Yeah, but it'll be easier, won't it, to have it in the table and just look up 0 each time for them until they crash. And then you go through 1 to 8 once it's landed.
Hang on.
No, Rob.
Oh, there's a specific class for Skylab. Look, there's a specific class for Skylab, so we don't need to do it because that'll be handled in the sprite animation routine. Right. So, how many others we got? So we've got a 4 there. 1, 2, 3, 4. 4 there. That's the 8. That can be the same as mine or Wiele. 4 frames there. 4 frames there. 4, 4. And this is special, so I don't need to worry about that. Right, so we just need to work out the indexes. So
Well, I'll just do the sprite number times 8, won't it?
yeah, well, that's what I'm thinking, right? Because if we do 8 frames is 0, 1, 2, 3, 4. Now I'm just wondering whether to actually put 0 as the frame, and then this would be 8, this would be 16, and this would be 24. So we don't have to work out where the index is. We'd actually say that it's
even better, yeah.
Yeah, and follow on the sort of logic in there. Right, so we need to then now I am just wondering. We're not going to get any code written today, are we?
You owe me 10 lines.
Say again.
You owe me 10 lines.
Well, I'll have written 10 lines, mate. Don't worry about that.
I think them deleting that don't work doesn't count.
Right.
What did I tell you on Monday, Andy?
I've slept since then. What did you tell me?
Stop making me laugh.
Oh, sorry.
You're making me cough.
Sorry, mate.
Right, Sprite. Miner Wiele. So he's going to be 0, yeah? So let's put all the... right, I'm just going to move this over here. So I'm just going to put this over here. So if anybody's talking in chat, you're going to have to listen, because I probably won't see it while I've got this over here. Right, so we've got robot. Which is going to be 8, yeah? And then we've got penguin, which is going to be 8, 9, 10, 11, 12. Chicken. In fact, no, we haven't got the lengths in there. So chicken's gonna be 12, 13, 14, 15. Toilet is going to be 15, 16, 17, 18. Sea lion. Is that how you spell it? Sea lion?
Yep.
So sea lion's going to be 18, 19, 20, 21. Now the sea lion's 4. So eyeball is going to be 21, 22, 23, 24, 25. Oh, yep. Next one is fireball. Now the eyeball's 4 frames, so that's 29, 25, 26, 27, 28, 29. Telephone. Oh, come on. So the fireball is 4, so 29, 30, 31, 32, 33. Eugene. Eugene. E-U-E-N-E. So the telephones are 3, so that's 30, 33, 34, 35, 36. How about dot constant plus length of next sprite animation? Is it possible? But we don't know what the length is. That's the problem. That's the problem. I thought of doing that, but we haven't got the lengths in there. So we'll just do them. I didn't want to put lengths in because we're never going to use them because we're going to always be eight frames. Right, what's the next one? Is it the teddy bear? Oh, bunny. So that's 37 because Eugene is only 1. Now bunny's 5. So what's this? Pac-Man. So the bunny's 5, yeah? 1, 2, 3, 4, 5. So 7, 38, 39, 40, 41, 42. What's that? Kong. So Pac's 3, so 42, 43, 44, 45. What's that one? Kong Fall. So 3, so that's 48. What's that? Kangaroo. So Kong Fall is 3, so that's 51. 48, 49, 50, 51. Yeah. What's the next one? Wheeled thingy. So kangaroo's 4, so that's going to be 55. 51, 52, 53, 54, 55, yeah. Wheeled thingy is 4. So what's this one? Amoeba. A-M-E-O-B-A. So the wheeled thingy is 4, so that's going to be 59. Yeah. So amoeba is 3, so what's that? What's that called? Mobile antennae. So the amoeba's 3, so that's 62. Let me know if I'm getting any of these numbers wrong. What's that? Pogo eyes. So the mobile antennae is 4, so 62 plus 4 is 66. Pogo, so what's the next one? Oh, Skylab, isn't it? Ooh. So Pogo Eyes is 4, so that's going to be 70. Right, what's next? Bank Box. So Skylab is 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 78. 71, 2, 3, 4, 5, 6, 7. Yeah, 78. Oh, John. That's annoying. Right. Right.
You knocked the Y off wheeled thingy.
Thank you.
If you want to keep the name, it's not important, but
no, that's oh, money. Right, so the bank box was 4, so that's going to be 82. Flagtail. So money's 4, so that's going to be 86. What's that? Walker. Oh, come on. Flagtail was 4, so that's going to be 90. Next one is Warehouse. 94, because the Walker was 4. Next one is Jellyfish. 98, because the Warehouse is 4. Solar Ball. 102, because the Jellyfish was 4. Solar Truck. Plus 4 is 106. What's that one? Headlight.
I've got flashing keys.
You got flashing keys?
Yeah.
Oh, on yours you mean?
Yeah.
Nice.
Just thought I'd tell you that. Oh,
Nice,
interesting.
nice, mate, nice.
It was stupendously harder than it should have been.
Leg. Right, 112 spikes. So we've got 108 here, plus the 8 of Wiele. That's 112. No, that's not right. I've gone wrong somewhere there.
How many have you got?
Right, we have 108 in that set. Yeah, and we have 8 on Minor Wiele.
That's 116.
Yeah, so I've gone wrong somewhere. So there's definitely 8 there. Right, let's work this out then. Let's do this right. So, oh, well, it's 113 if... Yeah. Okay, where have I gone wrong? Right. Robot Walker is 4. Yeah. Penguin is 3. Chicken is 3. Toilet is 3. Oh, okay. Sea Line's 4. That's right. Eyes 4. That's right. Fireball is 4. Yeah. Telephone is 3. Eugene is 1. Bunny is 7. Sorry, 5. That's right. Pac-Man's 3. Yeah. 3. 3. Kangaroo is 4. Yeah. 4. Amoeba is 3. Yeah. Oh, was it called Barrel? Right. Kangaroo's 4, we did that. Real Thingy is 4, that's right. Amoeba's 3, that's right. Antenna is 4. That's right. Pogo is 4. That's right. Skylab's 8. Bank box is 4. Money is 4. Tails is 4. Walker is 4. Warehouse is 4. Jellyfish is 4. 4. 4. Ah, that's where I've gone wrong. That's where I've gone wrong. Right at the beginning end. So
Sprite headlight is 4, isn't it?
Yeah. Yeah. There we go. Right. So we have 108 plus 8. 116, yeah?
Up to 115, yeah.
Including 0 is 116. Right. So we've got all
I'm
that.
not sure even where to use the leg sprite, John.
Say again.
The leg sprite, I'm not sure you're able to use that because you have to draw that a number of times down. Oh no, we can have lots of sprites.
We've got as many sprites as we want, innit?
Yeah, 128.
Yeah. So,
you're going to be continuously overwriting, right? Yeah.
Say again.
So you don't need 115 hardware sprites. You just really find the ones that are being used on that screen.
Now, there's 116 sprite data sets, but we only need however many sprites we've got on the screen.
Oh, only 8 sprites on the screen. Yeah.
Yeah, so that's what I'm saying. Oh, you need to copy up.
No, you say sprite 1 is frame sprite 59.
Exactly.
It's fine, yeah.
I'm just thinking of sprite space in Vera, that's all.
Well, once we've copied all the data into Vera, yeah, we should be alright, shouldn't we?
Yeah, but how big's the sprite and how many sprites have you got? This is what I'm saying.
I think it came to about 17 or 18k for sprites, that's all.
And we're still missing some door sprites, but they're only not going to be multicolours. They're going to be single colour. Oh, what was I doing? What was I doing? Oh yeah, that's what I was doing.
I've just worked it out as 64Ks with the sprites, that's all.
Yours is?
No, yours is. Because you got 32 times 16 bytes per sprite, and then you got 115 sprites.
Yeah, each sprite is 128 bytes, yeah? Times 116 is 14k, 15k.
Okay.
Right, 3 and 5. Right, so that's going to be 0, that's going to be 8, that's going to be 16, and that's going to be 24. Everybody agree with that? 8 sprite, 8. Right.
How are you working it out again, John? Because I've just worked it back out again. So it's 30. Oh, it's 32 pixels. Shut up, Andrew. Okay, don't worry.
16 by...
No, it's all right, mate.
We've only got 16 by 16 sprites, yeah?
Yeah, I worked out as 32 pixels, 32 bytes wide, not 32 pixels wide. Because the color information has got 4 bytes.
Yeah.
It's all right.
No
I've got my head stuck in Mega 65. Sorry.
No worries. No worries. Right. So if we're going to use this setup that we've just created in here, right, we can try it out on Miner Wiele, yeah? So if we get rid of that, going to render, and let's so build sprite animation array. Right, here's the 10 lines of code, everybody. Right, so input.
Including comments.
Input. Right, so x equals sprite frame initial sprite frame, and y is going to equal the animation sequence start point. Alright, and we will have another one, A, which is going to be sprite number. So that's going to be between 0 and 7. Right then. Right, so first things first, we need to multiply the sprite number by 8. So ASL 2, 4, 8. Okay. Then store that into sprite array start index. Right, okay. Transfer, okay. Sorry guys, I've got something missing. Oh yeah, she's around. Alright Fairlane, see you later mate. See you later. Right, so we store that in the sprite array start index. What am I going to be working first? Let's work out the animation sequence start point, which we know because Y will have that. Right. Right, so store X into sprite adder. Right, so now we can use X. Right, okay. So LDX has 0. So load A with. No, we're always going to have 8. We're not going to have anything less than 8. Right. Okay. Right. So load. Load the. We want to load the animation sequence, don't we? So that is going to be that game data. That right. Game data, comma Y, because that's the start point. Then we're going to clear the carry. And then we're going to add not that, we're going to add that. So if it's the robot walker, we're always going to be adding 8 to it, right? And then store it in there, storage render that, storage dot render dot that, comma
I'm going to love you and leave you now, John. Thank you.
All right, mate.
No, mate.
See you later.
Catch you later. Cheers, bye.
See you later.
Bye.
Cheers.
It needs to be that plus your sprite array index, start index that you've calculated, doesn't it?
Yeah. Just need to create one of those. So STZ index. Right, so this is our start index, so we can transfer that in. Right, let's get this in the right order. So if we save that first, then we can work that out and transfer that into X. We initialize our index, then we can do that, store it in our frame sprite because that is our start point. In fact, we don't need that, do we? Transfer it, that's the start point. Then increase Y, increase X, and then inc index, LDA index, compare it with 8, branch if not equal to looper, RTS.
That makes sense.
Yeah. Right, let's try it on Miner Wiele. That'll be the test. That'll be the test. So so instead of doing this, if we load right, so A is our sprite number. So load A with 0 because it's sprite 0. Load Y with the start point. So LDY hash sprite Miner Wiele. LDX hash sprite animation. Oh, did I call it sprite animation? Oh no, there we go. Sprite 8 frames, yeah? JSR game. Is it game render? I call it. Yeah, render dot build sprite animation array. Take that away. Right. If our working out is right, this should work. Well, we're on a winner. Miner Willie's on the screen. Here we go. Right. Did I hard code this in here? Draw. Yeah, I did the sprite frames. That works. Right, so let's try this with something else. So if I do sprite the robot, yeah, and it's a 4 frames. If we run this, we should end up, and we don't. Oh, there he is. There we go. Right. Okay. Let's try the others.
Try a 3 frame.
Say again.
Need to try a 3 frame to see if it animates right.
Yeah. 3 frame. So that's a 4. So we'll go with Pac-Man. Sprite Pac-Man, sprite 3 frames. Right, let's see if we get a... So the initial frame is because Miner Willie is initialized, right? But as soon as we move... Oh...
That don't look right.
No, it doesn't, does it? Right. Let's put a breakpoint. Let's find out what's going on.
It's a bit confusing because the 4 frame worked.
Yeah. Right, so we're going to jump into...
So it looks like a multiply issue.
Say again?
It looks like a multiply issue.
Yeah.
Where the frame count is being multiplied by 3.
Yeah, we're not doing that. We just got a byte sequence.
Right, so sprite 0 and the Pac-Man is frame... Oh, rats. Oh, frame 28. So that is what? 28 is 32 plus 2A, sorry. 32 plus 10 is 42. And we've got 35 plus 8 is 42. Yeah, that's right. And X is index 10. Index 10, let's have a look. Index 10. Yeah, that's right. 16.
16, right.
Right, okay, so we've set up the registers, okay? So let's jump in and see what happens. So we store X, which is 10, in 11A4, which will be this number here. There it is.
Yeah.
And then we're going to multiply A by 8, but it's going to be 0 anyway. Transfer it into X. Then we initialize our index. This is our
that should be the animation table, shouldn't it? So that should get 0, 1, 2, 1, etc.
Yeah, that's the sequence. This is the sequence. That's the sequence. Yeah, so we should get a 0. Oh, why do we get a C?
We worked that out wrong somewhere then.
Right. Game data.
Hold on, John. What's in Y? No, it was right. It was game sprint plus 16, wasn't it? No, why got 2A in it? I thought that was 16. Or it actually was 16.
Yeah, hang on. So we're getting Y is the animation sequence start point.
Which should have been 16, shouldn't it?
Have I got them the wrong way round? Hang on. Right, let's put that there. It's got a Manic Miner. Have I got them the wrong way round? Let's have a look. Y is... Oh, yeah, I've got them the wrong way round.
Wrong way round, John.
Yeah, I got them the wrong way round.
We just got lucky on them.
Yeah, got lucky on the first ones. Right, let's take the breakpoint out. Let's try that again. Right, so we know it's Manic. There we go. Right, so that's a 3. So we've done an 8, we've done a 4, we've done a 3. So that's
5. Kangaroo was 5, wasn't it?
Oh yeah, there was a 5, yeah. That was Bunny. Bunny. Right, here we go. There's something wrong there.
Did you change it to 5 frame? I didn't see you change it.
Oh yeah, it's still on 3 frames. I thought it looked funny.
I thought my Twitch had just glitched and you changed it and run it without me noticing.
No. Right, here we go. Oh, wrong keys. That's better. Oh, that looks like an evil bunny though, doesn't it? That looks an evil bunny. Oh dear. These sprites are brilliant. Right, let's run through them, see what they look like. So I'm gonna do all the 3s, alright? So we're gonna do all the 3s to start with. I want to see all these sprites running. So penguin. Right, let's see them. Right. Oh, brilliant. Right, I'm going to change it back to 0 so we've got plenty of space to move. without anything getting in the way. Oh, what? Oh, that one. There we go. That looks brilliant. Right, chicken.
I thought your conveyors were working.
Say again?
I thought the conveyors were working.
The compares?
Conveyors.
No, the conveyors only work on the game cycle, mate. I've set up the characters, but I haven't done the game cycle yet.
Oh, okay, I thought I'd seen it working. It's alright.
No, I've done the redoing of the frames, but we haven't got the cycling going yet. Right, so this is the chicken. What's the next three? Toilet.
I think technically they're ostriches.
It was an ostrich. Right, here's the toilet. Look at the back end of it.
That's excellent.
Right. Oh dear. Right. What's the next one? Telephone. Hang on, is the telephone's not a 3, is it?
Is it not?
No, it's a 4. Telephone's a 4, but it's not in the same sequence. Hang on. Four is... No, 3 is 0, 1. 0, 1. Yeah, it's a different sequence. Right. So we're gonna have to call this 3 alternative. So frame 0 is frames 1 to 3. So that's frames 0 and 2. 0 and 2. Then, oh, hang on, 0 and 2, 0 and 2. Frame 1 is 1, yeah. And frame 2 is 3. So, there. Right. Let's just put that in there and see what that looks like now. Ooh. Why is it not liking that?
Because you haven't defined 3 alt frames as a number. It needs to be whatever it is.
Yes, you are right.
40, 32, yeah, 32.
Yeah. Right, let's try that. Right, here we go. That's better. Oh dear, brilliant. Right, so we've done Pac-Man. Right, so next one's Kong. That, look, you say I've deleted. What have I deleted?
It was when you were doing the ultimate 3 frames thing.
Oh, right. That Kong looked right, didn't it? One. Yeah, because that's... Yeah, the Kongs look right. Right, Kong fall. Kong fall. So he's upside down. He looks like he's doing that with his fingers. Oh, look at this. I can walk on my fingers. Oh dear. Oh dear. Right, what's next? Amoeba. Yeah. Nice. God, even the flipping of it makes it look like it's going in the right direction, doesn't it? Yeah, please stop. You've had your one warning, mate. Carry on. Right.
Go for the wrath of Andy.
Yeah. Right, so they're all the 3s. Right, they're all the 3s. Right, let's do the 4s. So, the first 4 frame is the sea lion, isn't it? Sea lion. Right, so I'm liking seeing all these finally animate. Here we go. Oh, that's brilliant. That is brilliant. That is brilliant. Oh, eyeball. Wrong key. Oh, that is very nice. That is very nice. I've never seen anyone do assembly. Yeah, it can be when it all works. Can be when it all works. So this one's the barrel, yeah.
And it's fun for us watching when it doesn't work.
When it doesn't work. Yeah. Right, so this is the barrel. Oh, that is nice. That is very nice. Nice. He's outdone himself this time, hasn't he?
done some sterling work here, SP.
Yeah, kangaroo. Yeah, that's definitely a fort. Kangaroo. Oh, it's brilliant. Oh, it's great seeing these things move. Right, wheelie thing. Nice. God, even the wheels look like they're turning. Nice. What's next? What's next? We've done the amoeba. That is the... Oh, mobile antenna. Right. Mobile antenna.
It's really nice to see the original layout of, you know, the Manic Miner screen, but with all
these, yeah, ultra posh sprites. Yeah. I think it's going to work well, isn't it? That the background is still old school, but we've got new school for the sprites. Oh, that's very nice. Oh, I've got an itch. That's very nice. Right, what's next? Pogo. Yeah. Right.
I think it'd spoil it if we did cold hands. I think it looks nice with the instantly recognisable background.
Brilliant. Oh, I'm gonna have. Oh, I'm not gonna be able to play this game. I'm telling you, I'm not gonna be able to play this game. Right, what's next? Bank box. I'm gonna be laughing so much at the graphics on it. Right, here we go. Here's the bank box. Oh, that is brilliant. And terrifying too. That is brilliant. Oh, money. Money's next, isn't it? I was just checking the animation, mate. I wasn't sure if it was doing it right, but it is. I like the background as it is. I think it's a nod to the original, but we're flagtails. We're bringing it up to date. I think the mixing of old school and new school does work, I think. Oh, wicked. Look at that. That is excellent.
You should go up.
Yeah.
Not down.
But the game has physics.
Who's joined? Acmafin. Hello, mate. How you doing? This is brilliant. That is brilliant. I love that one. Oh, Walker. Right. That's Beebcadia. It's Beebcadia. That's brilliant. Oh, that's brilliant. What we got? Warehouse. Yeah, just making sure that it was right. That looks good. Right, this is jellyfish, isn't it? Yeah, jellyfish. Oh dear. Right, what's that one? Solar ball. Oh, nice. And the reverse works as well. That's an added bonus that the reverse works as well. Solar truck. Is it truck? Yeah. Yeah. There we go. Oh, right. Okay. We may have a problem with that one. Nothing that I can't handle. We'll have to do something about that one. But that works very well. Yeah, it always faces left, so we'll have to do something about that one.
Yeah, just treat special condition on that level.
Yeah, yeah. Headlight. God, that's the Borg. Resistance is futile. Right, and the last one is the Skylab. But that's an 8 frame.
More or less. Some levels have got several different.
Nice. Nice. Right, that's working, isn't it? This our little sprite animation engine is working, isn't it? We just need to run that routine on all the sprites that are going to be on this screen. Right, what have I missed? What have I missed?
So you're going to need somewhere keeping track of how many sprites are actually on this page.
Well, that's
to use.
Well,
but I think it's in the other table already, isn't it?
Yeah, it's in this frame table here. So all we're going to have to do is that would be sprite 1 because sprite 0 is taken by Minor Willie, and then sprite 2. So we just add when we build it up. Each one of these lines would be the thing. But I think what we're going to have to do is we may have to create labels. Oh, but we don't need to because we got it down here. Yeah. So that's our count. So it's just basically that plus 1.
Yep. Ooh, there's one with 8 sprites on it. Level 10. 9 sprites on level 17.
Level 17.
Is that the Skylab collapsing? It has to collapse through 17 lines of crunch, doesn't it? Is it just collapsing into the floor?
No, this is the number of sprites on the screen. So, hang on. I'm just going to fire up C60. I'm going to fire up the C64 emulator.
There's no screens with 17 sprites on.
No, 9 sprites.
Yeah, 9 sprites. That's what it's put. Which means it's 10 including...
Just need to make your array bigger, that's all.
Yeah.
Yeah, but there can't be because the 64's only got 8 sprites.
Yeah. Right, I'm just going to load up that.
Well, there's a couple of there's a level that said 8 as well, which is 9 including Wiele.
Right, so
I thought that the other day when we went through it, John couldn't find them.
Right, Amoebatron's Revenge, alright? Go away. Right, start game. Right, what did I say it was this one. So Amoebatron's Revenge, yeah? One, two, 3, 4, 5, 6. There's only 8 on there.
This is what I said the other day, and you counted them, and there wasn't.
Right. So this number is the number of bad guys on the screen.
No, just go to the table.
Right.
Because that lists all the sprites that are on that level.
Yeah. 1, 2, 3, 4, 5, 6, 7.
The exit is a sprite, yes.
So there's 9. There's 4 79s, 4 139s, and a exit.
Yeah. 4 79s. I wonder what the 79 was. Hang on. Let's look at the original, see what 79 was. Oh, there. 101. Right, let's go down. 79. Right, 79 is...
The keys are characters.
Yeah, so 79 is the walking pole. 139. So we've got 4... Right. So that is saying 4 walking poles. But there's only 1.
There's only one on
there's
that.
2. There's 1 up here as well.
What's the thing that SV's linked in chat?
Right, 1, 2, 3, 4, 5, 6. Oh, right, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah, 4 of each, Gate and Wiele, that's 9 plus 1.
But the problem is, he's done it. So he has reverse engineered this into C, but then. Okay.
He's worked within the bounds of the C64 limits.
Yeah. Hang on, I'm bookmarking that.
That was what I was referring to when I was talking to you last week. And then you went and showed the gameplay, and that must be where I got it from, because I've got that. That's what I've been working with.
We don't need to do a multiplexer. We don't need to do a multiplexer because the X16 has if someone corrects me, 128 sprites.
Correct. I use 80 odd in Space Invaders.
So this storage needs to go up then. So we need to say 10, yeah?
Yeah.
So that's 9 plus Minor Willie, yeah? Right. Yeah, 128 sprites for the Commander X16.
Plus, you can't do a multiplex on the Commander X16 because everything gets written on the flyback.
Where do you need char graphics for them?
That's just how it was done, Atmosphere. That was just basically how the data was laid out.
Yeah, so we've got so it's characters for the background and sprites for the bad guys. All done. These are all the sprites. SP has worked his magic, and I do love them. Hang on, everything's gone away. I've lost chat and everything. Hang on. There we go. Right. So everybody give SP some love because he's done an amazing job on those sprites. Amazing job. Right. So I've done more than 10 lines of code, so I don't owe Andy anything now.
Just keeping you on your toes.
So we'll keep this as the initiator for Minor Willie. So we need to start working out how we're going to set up the sprites for the rest of it. So I need to think. Oh, we needed another... That was the thing. We needed another constant, didn't we? Have I got another constant that I can use? Please tell me I've got one free. Please tell me I've got one free. No. Pants.
What for?
The reflector, so it wouldn't change direction. But is it the only one on the level? Hang on.
There's like 4 of them, and
oh, it's got the solar balls as well. Okay. Oh, pants. I wonder what this extend max X is.
I bet that's for sprites that cross the 256 characters X position.
Let's have a look. Let's see which one's got it. There.
I reckon those sprites can be 64 by 64 pixels in 256 color mode. So it's got quite a lot of sprites.
So levels 7 and 11. Levels 7 and 11. Levels 7. Oh no, that's 7, isn't it? 0, 1, 2, 3, 4, 5, 6, 7. So what's the extended then?
Are they counting levels from 0 or 1?
It's 0.
Yeah, you are, but on those pictures, are they?
Well, that's why I counted. So I went 0, 1, 2, 3, 4, 5, 6, 7.
Yeah, but
8, 9, 10, 11. What is the extended?
because I'm thinking if you go 1, 2, 3, 4, 5, 6, 7.
Let's have a look. 71. 71. I bet that's the barrel. 71.
No, what are all the parameters for it? Because there's a start X and a how far it moves or something.
Yeah, there's a start X and an end, so which is 124. But I'm just wondering what.
Is that the end or how far it moves?
That's how far it moves. Let me just find out.
Which is going to take it. Oh no, it's not going to take it past 256.
No. Right, let's go on to this one. Let's find where that one is. Here we go. There. So, if the extended in Sprite class. Oh, what's local storage? Oh no, hang on. If the Sprite class and extended is equal to local storage, is that what's that saying? So Sprite class and extended storage. Oh, I don't get off.
I don't know what that means.
No, I don't. But it's saying Sprite X equals the Sprite local storage. I've no idea what that means. No, it's local storage populated, hang on. Right, local storage is this one here. No, they're all zeros.
Sprite memory?
Say again.
Is he swapping them in and out of Sprite memory?
I don't know. I'm just one. It looks like one of the barrels in 7 has this extended max on it, and I'm just wondering if it's.
Oh, is it?
Is it this one? Does the switch open this wall up?
Yes.
So what it is, John, is it starts at 88. Go on, flip through to.
That one. Oh, I'm dying.
So the switch on the left opens the wall, and the switch on the right drops the monkey.
And when the wall opens, that barrel can go across to that other platform.
Because this one is slower than the others, right? The speed of this one is slower than the others, right? Oh, that's doing my head in.
Pause it.
Right. The speed of that one is slower than everybody else's. But is that the speed?
Yeah, the one is the speed.
The one is the speed. So that's fast. That's fast.
Or is that move 1 pixel per cycle as opposed to 2?
Well, that's what I was thinking.
Which is slower.
Yeah, that's what I was just about to look at. See if it's moving 1 pixel.
Is it added to the speed?
Hang on.
Because everything moves at uniform speed, and that could be adding -1 decreases it.
No, I think it moves 1 pixel per frame, whereas others move 2.
Right, so there's 2 moving at the same speed, and only 1's moving slower. So out of the 3 barrels, we have 2 running at the same speed and 1's running slower. So I bet I put money on it, and I bet I won't be able to do it because I'm rubbish at this game. Told you I was rubbish. I'm stuck.
Yeah, but at least it's not crashing now.
Oh. I'm gonna be here forever. Oh, turn! Willie, turn! Oh. Oh, this is annoying. How do I get out of that?
You have to keep pressing left when you jump out.
Oh. I thought
you can't turn when you're on the conveyor.
Oh, I'm alright. Alright. Here we go. Jump. Oh dear. Jump. No. Oh, come on. You can tell I've never played this game before. Oh, I can't do that. I can see me not being able to play this game. Jump. Oh.
You have to jump on the box and jump immediately onto the platform.
Jump onto the...
In the box. And then when you jump out of the box, you have to keep pressing right or left. Now. So you jump out and you jump immediately. Jump. No, immediately.
So as soon as I land in, I've got to jump in immediately.
No, as soon as the purple one goes past you, going left,
yeah,
you jump out, keep holding left and jump again.
I'm glad I got infinite lives. Oh, I see what you mean.
Yeah.
Oh, I'm catching him up.
Yeah, you jump immediately. That's what I'm saying. That's what immediate means.
I can't do this. This is going to be frustrating for me.
You jump straight. Jump immediately when you jump. So jump into the box. Let it pass you. Then go and then jump.
Oh. Oh.
I hope someone's clipping this.
Oh dear. Oh, no, I'm
Why don't you look on YouTube? Let someone else do it for you.
Rage quit, yeah. I'm not going to be able to test these levels. I think that's to do with extending.
What's the other level that it's used on?
It's the same thing, mate. It's this one. This one. So that, I bet that goes all the way across to there and then back again. As this one would go all the way to there and then back again, I think.
Yep, makes sense.
So, so yeah, the solar trucks, I can't use the masking on this because all 8 bits are being used. Because that's what all this lot's all about.
But they're only on the one level, so you just need to, in your game loop, if the level is this.
And the sprite, yeah.
And the sprite is this number range, then don't flip the reverse.
Yeah. Right. Let's see if we can get one of the sprites on the screen by getting the setup done. Right. So, what did I call the other ones? Here we go. Prep level sprites. Woo. Right. Right. It goes as far as the bush. Who's doing cheeky? That's why most players haven't seen this level before. Well, I've never seen it. I've never. Well, let's just say I've probably only got to level 3. Right. So, need to think how we're going to do this. How we're going to do this. So we need to take note of the sprite array and set up every sprite. So I need to check the macro for setting up a sprite. Set sprite address in Vera. Move. This is the setup, isn't it? Is that doing... No. How did we set up Miner Willie? Set up sprite. So sprite memory address.
Is the 0 the sprite number?
You mean the first one?
Yeah.
Yeah, that's the sprite number, yeah. I think that's the X and Y. Why is it not finding the macro? I have no idea. Let's go on the macro. Where's the macro? There. So sprite number, where the address of, I presume that's the address of the sprite. Mode, X and Y, height and width, and the palette offset. Because we haven't spoken about the palette. We just showed them in the default thingy palette, didn't we?
Yeah.
Yeah. So, if I set up this as, say, sprite address, that would set it to Miner Wiele.
But you're passing that a 17-bit number, aren't you?
Yeah. Because
John, I'm going to do one, mate, 'cause I've got stuff to do in the morning. I need to get up, so I'll catch you next time.
Alright then, mate. Alright.
Right, Andy.
See you guys.
So, I'm just... sprite number is actually a number, isn't it? Yeah. It's not an address. Same with this. This is not a memory location. It's actually what we're sending in. So the question is, do I do a loop or
So do you need a version of that where you can pass it the sprite number
yeah.
and calculate the base address from that?
Yeah. So the base address would be this table. So basically we need a version of this where we can send in a memory address of the sprite number. I think. Because we could hard right. Yeah, so we need to basically do this, but on that one a bit further up. Right, so we're gonna have to, is that left shift in 3?
Yeah.
Oh, that's setting the Vera address to point to the sprite table, isn't it? Hang on. Right, so it's not that. Oh, let's go onto the site. So the Vera address is pointing to the table of this, isn't it? And that's why you're multiplying it by 8.
Yeah.
Okay.
So like, first one is sprite 1, 0 is there, sprite 1 is
8.
That base plus 8, yeah. And then you've got the 8 bytes of data to fill in.
Yeah. So we need to, yeah, okay. So let's take this. I'm just wondering whether when we set up the Vera, we'll set up the initial frame rather than the sprite address, and use that other function to get the right one. This one. No, not that one. That one. Yeah. Where are we? Set up sprite in Vera. Right. Set up sprite in Vera by we'll just call it 2. Right, sprite number is the address of the sprite number, address of the sprite address, but I'm just wondering whether to do just sprite frame.
Yeah, no, I think that's the better way of doing it, and work out the address from the frame number.
Yeah. The rest can be as is. Oh no, because we'll need the. How many? The X position is going to be a word, isn't it?
Yes. Oh, hold on. How many? Yeah, it will be. How wide is your screen?
Well, it's 16. It's 16. It's 32. It's 32 wide. Yeah, which is 256. No, it can be a byte.
It can be a byte.
Yeah, but we'll have to put an offset in. Yeah. So game constants. Where's our offset? There. Right, so we'll do the same thing. A const sprite offset x, which equals that times 8. And did we do the offset for going down?
Why do you need an X offset? I'm lost.
Remember, we've padded it over, didn't we, to center it on the screen? So that's the offset.
So you, which will make it bigger than a byte.
Yeah,
if
but,
you get near
in the macro, we can convert it into a word, can't we, when we add the value to
you
it?
pass it. You can pass it a byte, convert to a word. Yeah.
Yeah. I'm sure. Where did we do? Hang on. Where did we? So that's prepping the screen, but it's not the screen, is it? It's the copying across. Where's the copy? Clear. Here we go. Copy to Vera. Oh, there. AB. So we did 3 characters. We did 3 rows.
Yeah, I'm just a bit full, so I'm going to come back to
All
that.
right.
We're going to set up a base.
Hey, did Tash?
Hello, I know that voice. Hello. How did your Red Deading go? Hello. How did your Red Deading go? Not bad. Did you do what you needed to do? Did you play with your new gun? Right, macro. Yep, blew a man's head right off. Hang on, you was watching Fallout with me, and you kept turning away every time that happened. Is it all right in a game? Is it? You can't have double standards like that. Right, I am lost. How can you watch? How can you turn your face away from a person having his head blown off on telly in Fallout, but it's all right in a game? Can't do that. Can't. Right. So if there's 128. All right then. Night. Well, I'll talk to you tomorrow, yeah? And then you can tell me all about it.
Alright.
Right, 128 times 8. Right.
Big number.
Yeah, big number.
Or you do it the way we did it earlier. Put it in the big number and divide it by 2.
Would that work?
Yeah, put it into high and divide by 2.
Alright, so if we say sprite 8, yeah? And
Yeah. Go on. So you make it 800. And then divide by 2, or shift left, shift right, which is divide by 2.
That doesn't look... Oh, I'm doing decimal 8800. Right, so divide by 2. That's not right, because if 8 would be there, wouldn't it? And we're only moving up 3. We're only timesing by 8.
Oh, sorry, you're timesing by 8, yeah, sorry.
Yeah, we're only timesing by 8.
I thought we were timesing by 128 for some reason.
No. So I was...
Right, forget all that. Forget what I said. I'm thinking of something else.
Right, I'm gonna write something in here, and you can tell me if it'll work or not. Yeah.
Well, one of us will.
Right, LDA sprite number. So now so it'll have to be straight away.
Yeah, well, because it could be as high as 100 and something, couldn't it?
Yeah. So do that 3 times. Yeah. And then store the...
Actually, what's the highest sprite number, John?
Say again?
What's the highest number? It's only 116 or something, isn't it?
Well, technically, mate, we're only going to have 8, aren't we?
Oh, this is just sprite number, yes.
But if we're going to use this macro for everything, we've got to be able to cater for everything, yeah?
Yeah.
So what I'm thinking of is zeroing out the high,
and rotate. Yeah, it's all right.
It in, yeah, and then do this to the high byte. That should work.
No.
No, it won't. No. I need to do that. Now that should work.
That might work, yeah.
Right. So we'll leave this the same. Right. The X position. But the problem is if we're going to use this for other things as well. Right, let me just do the sprite. Now this is gonna have to be unique for this, isn't it? Because that's the address. Right, so that's the address there. So we're sending in the sprite initial frame, which is that. And then that goes off to the sprite address. And then we get rid of that.
Yeah.
No, we'll make this unique to this, mate. So I could see what you were saying here. We don't store 0 there, and then we only do the ASL, yeah.
Yeah, but if you're going to make it so it works for any number of sprites.
Yeah, the problem is that the sprite table in this one, you know, this sprite table probably won't exist anywhere else. Yeah.
Yeah. All right then.
Or am I just overthinking it? I'll leave it at that. I'll leave it at that. It'll work for here. So for the X position, we are going to load load our X position, add our offset, store it in Vera, then load 0, ADC hash 0, store it in Vera. That will do it, won't it? To get the high byte,
Yep.
Now Y position, we're never going to go down low enough, because it's 16 rows, so 16 times 8.
No, you're not going to go far enough down.
No. So we can do Y position, CLC, ADC, that, but it's Y, store it in Vera, and then load 0, store it in Vera. And then they can stay the same. Right. So we need some variable addresses. So we need I've got to be careful that I'm not going to. No, I'm not using any storage in the macros. So this is going to be frame init frame number dot label sprite number we know the level because that's set elsewhere. Maximum number of sprites. Right. We didn't make this array 16, did we? It's still 15, isn't it?
That level, yeah, that's still 15.
It's because it was 0 to 14, wasn't it? 0.
Correct.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right. We was thinking, what was we thinking? Oh, the frame, wasn't it? We was thinking of adding the frame, the animation frame, wasn't it?
Yeah, the animation pattern, yes.
Yeah, so if we do Let's put the animation pattern there. There. So we'll just put 0 in there. Because that's going to be the... so we'll leave the colour in. Now we can multiply by 16, can't we? When we run through it. Right, so we know the level, so we need to grab it from here. Right. So LDA storage dot render dot m underscore level times it by 2. Now we've got 20, so it's only going to be still within a byte. Transfer into X. Right, so load. Right, so that's going to be the right array byte index because that's going to be 2 bytes. So the array is 16, so we need to multiply it by 16. So if we do this, load that, times it by 2, times it by 4, times it by 8, times it by 16. And then do roll into that. Okay, and then store into that. That'll work out our offset address for our game data here. Or will it? Hang on.
Yeah, because that's...
Yes, this is the index, isn't it? This is the line index. Yeah, so that'll work out our base offset. So then we need to CLC load. Well, oops, don't need to store that, do we? We just CLC ADC hash that game data that game data that store it in that right, that gives us our offset. Right, that gives us our offset. Okay.
Might as well grab the number of sprites while we've got a pointer.
Yes. Which is that one there. Right, so that's got our point and our maximum number of sprites. The voice in my back of the head shouting at me. It's telling me that we need to store this permanently because we're going to be updating values in that table. So yeah, because now we've worked it out, we should store it away. So the voice in the back of my head giving me grief. Right, so how are we going to do this? So do we loop through sprite numbers and then work out the offset from the sprite number? Well, we've got the sprite number there, so we could do it. So if we do store in sprite number, I rely on that little voice in the back of my head because it tells me when I'm potentially doing something wrong.
Do you want to put a 0 in there, or do you want to put a 1 in there?
Yeah, I was just thinking that myself.
Because zeros, Wiele into it.
Wiele, yeah.
And that works better for comparing against max sprites when you're looping round.
Well, if it's 2, it's going to be +1, isn't it?
Actually, yeah, it is. Well, we'll deal with that when you come to the loop.
I'm just wondering whether just to load, just do and add 1 to it.
May as well, yeah. Then you can use it for a compare.
Yeah.
Just ink.
Yeah. Oh, does ink work?
Ink increments the accumulator. Same as iron X and iron Y.
Right, and we'll see. Right, so we start. I'm just wondering. Hang on. If we're starting at sprite 1, that will affect the sprite 1 in the frame array that we've just built. Okay. Right, so we then need to so we've got this game array now. So if we load Y with 0 and then do load that, comma Y, that's going to give us the current value. that is going to give us this current position. So I think I need to make some more constants. I think I need to make some more constants. So let's do it down here. Right, here we go. So dot const sprite array current position equals 0. Right. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's how many we've got. So this is going to be current frame 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15. Right, current frame. What's the next one? Current direction. Enabled. Local storage. Yeah, that'll do. Right. So min max start Hey Prodon, welcome in mate. Other axis, speed, frame index, color, start direction, start enabled, do anim pattern, and the last one is class. Right, so now we've got our constants in there. Let's go back to here. Right, so the first thing we want to do is read. We need to set X and right. Okay. Sprite class. So I think we need to load the sprite class in first. Oh, what did I call it? Oh, yeah. And then store that into there because that's going to drive everything. So let's start with the basics. Oh, hang on. Right, so what else do I need? What else am I going to need out of this that I've got to store away? We've got the frame number. Hey D-Type, welcome. How the progress is going? It's going slow, mate. It's going slow. We're setting up the sprite. Oh, start enabled. What's this? Why is it saying start enabled is 0? 0 for the door. Does that mean it's not on? Oh, I don't believe that for a second. Right, so let's do the X and Y. So we've got the class. So if we AND it with sprite class horizontal and oh no vertical branch if equal to 0, do horizontal. Right, so if it's vertical, then we need to load Y with sprite array start load that, store it in Y pos. Hang on, I think it's other axis, isn't it? Yeah, other axis. So sprite other axis, store that in xpos. We've got the sprites in. We've got the sprites. We've been playing with the sprites, so all SP sprites are in now. So that's doing that. So jump sort frame out or get frame. Yeah, get frame. Get init frame. Oh, I've done more than 10 lines now. I've got to have done more than 10 lines now. Right, so if it's not vertical, then it's horizontal. So the only difference here is that we're storing that in and that there. That's the difference. So now we need to get the frame. So a sprite frame index, I think it is, isn't it? Array frame index, and then we'll store that in initial frame number. Okay, need to make sure that that's still right. So we get the initial frame number. So we've got the X and Y, the initial frame number. What else do we need? What else do we need?
Animation pattern.
Yes. Did I put that up here? No. Gonna run out of temporary bytes here. So animation pattern, and store that in animation pattern. I think that's it. Right, where's Miner Willie? Let's grab this. But this time we are putting it in here. And it's 2. Right, so the sprite number is the first one. Then frame index, sprite mode, this is X pos, Y pos, right, that should do that. Right, I'm not saying that this is going to work, but I'm just gonna get it to do the first sprite, which in level 0 should be the yellow man. So if I've done this right, we should see a yellow man. If I've done this right, obviously not. Macro sprite number. Oh. Alright, see you later, FaZe. Oh, what have I just did? Go away. Manic Miner, F6. Okay. Why is that not liking that? Oh, hang on. Oh, okay, hang on. There we go. So we'll put it before mode. No, that's not what I want to do. That is what I want. Oh, it's in Mac. No, it's in here. So we did the frame, then that, then the mode. Yeah, right. Let's see if we get anywhere. Oh, give me a break. Oh, keep forgetting adder. I'm not doing it wrong that time. Right.
Yay! And you were worried it wouldn't work.
Yeah. We have an enemy. He doesn't do any. Yes, but we haven't got the door, right? We haven't got the door yet.
That's because you didn't do the next frame.
Yeah, but we haven't got the sprite for the door either.
Why not? Slacking.
we haven't got the door. Yeah, because they're gonna have to be one like a 64 sprite, because when we finish, we got to get the sprite changing the colours, haven't we? So we can't make it a multicolour sprite. But yes.
Yeah.
Or change the palette.
Yeah, you can change the palette for that one sprite with your palette offset.
Yeah.
Okay, so
I'm just wondering, is it worth spending 128 bytes when we can do it in what? 32 bytes.
Yeah, no, do it in 32 bytes.
So I'll get the doors created. Right, I've just noticed what time it is. So what I'm going to do is in here, going to put a to-do. Need to initialize the sprite data array with current values. So that's the first thing that we need to do. So we've set up
and loop round and do them all.
Oh yeah, we've got to go through and do them all. Complete the sprite loop. So that's going to be the next stream. So we're going to continue doing this.
Put another one in there, John, because you need to put the animation index thingy in the other table for all the lines.
Oh, and yeah, we've got to redefine the frame index with the new constants now.
Yes.
Is there anything else that we need to do on this? The exit.
I think that's enough to carry on with.
Oh, I've just realised as well. My offset worked as well, didn't it?
Yes, it drew him in the right place.
It put him in the right place. But is that right though? Hang on, let me fire the game up again. I'm not playing it because I rage quit. Does it start in that place? Yeah, hang on. Right, so I'm going to slow this right down. See where he starts. Where does he start? Oh, he started there. He started there. So, have I got the wrong address? Array start. Hang on, have I got the right column? So, yeah, start. That's where you start. I'm just wondering if my offset... Oh! John, you're a plank. Let me take the offset out. I'm just wondering if the...
Ah! What a plank.
I'm just wondering if the X offset is not required. Hang on. Where's the X? There. Let's just rem that out. Let's see, where's it? Right, okay.
So you did your offset times 3 or something, didn't you?
Oh yeah, hang on. I'm just let's see. Have I got the offset right?
times 8. Should it just be
hang on.
offset?
Yeah, hang on. Remember, the offset is with the colour, isn't it? We're just talking characters here. There we go. There we go.
Yep, that's right.
Bingo. Right, so.
All good.
Yeah. Right, so next time we'll finish off that sprite rendering, and then we will do the sprite update routine, which will then feed off that. So hopefully when we do the sprite update, we'll get the man going backwards and forwards, hopefully. It's looking like a proper game now. Yeah, we're getting there. We're getting there. Oh dear. Just brain fogging it. Right. Before I go, let's do this. So we are on episode 7. Right. Create a new branch. Right then guys, right, it's very late. I didn't realise what time it was getting into this. Thank you very much for joining me, and I will see you next time. Alright? Well, take care. Ta-ra for now.
Alright, mate.
See you later. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.